Hello, Miss Nidhi, are you there? I can see a Nidhi in the list.
Yes.
I hope
Hi,
it is
hi,
you.
Dr.
Okay.
Sarika.
So I'll pass on the presenter to you. And
Sure.
Monica also. I have made both of you as co-host, and I'll pass on the presenter to Nidhi. Is it?
Yeah.
Okay. Are both of you in the same physical geographical location right now, or sitting apart?
Yeah, we are at our respective hometowns.
Respective hometowns. Okay. Corona
So
situation.
I'm in Haryana. Yeah.
Okay. You are in Haryana.
Yeah.
Where? May I know?
Yeah, in Hisar, Haryana.
Okay. Okay. You are in Hisar. You are speaking from Kurukshetra.
Yeah, okay. Yeah, I have visited the place.
So, welcome to the session, Nidhi and Monica, both of you. So, dear participants, we have our speakers for today. They are already present in the meet. So, with a very brief introduction of both of them, they will be jointly delivering this session, and I hope all of you will enjoy it. As I already introduced in the morning itself, when Dr. Raghava was there, both of them are affiliated to the Cracker Lab. Now I'll pronounce it correctly as he told me. It is the Cracker Lab, Triple IT Delhi. Nidhi Goyal, who will be the first speaker, she is a PhD student there and a PM fellow also. She is working as a research intern in collaboration with Naukri.com. Her research interests include utilizing ML approaches, natural language processing, knowledge graphs, and knowledge graph embeddings for solving the real world problems. Then we have with us Monica Jain. She is again a PhD student and a receiver of Prime Minister Research Fellowship from the year 2020 to 24. And for her, the industry partner is CHIL. Her research interests are in the area of semantic web again, and she is developing an ontology learning system that will create an ontology from unstructured text. So both of them will provide the work they are pursuing, they are doing in this area. And I am at least really waiting to listen to you, dear. Please go ahead.
Thank you, Dr. Sarika, for a very nice introduction. And I am happy to be part of this FDP. Yeah, adding to this, I would say that I'm a PhD student at Triple IT Delhi working with Professor Raghava, who is headed by, who heads the Cracker Lab, and Professor PK, who heads the Precog Lab at Triple IT Hyderabad in collaboration with Info Edge India Limited, which is same as Naukri.com. Yeah, so I'll go ahead with sharing my screen. Since I have one device, I'll just stop the video to save the bandwidth.
Yeah, no problem.
Yeah. So is my screen visible?
Yes, we can see it.
Okay. So I'll start with, so today's talk will discuss about, me and Monica will both discuss about knowledge extraction and enrichment part. So the first part of the talk will be covered by me, the knowledge extraction part, and later on the enrichment part will be covered by Monica. So I'll start with a very high level overview of the topic, how we can So yeah, what are the topics that we want to cover in this talk? So first of all, I'll cover the information extraction part. What are the different challenges of information extraction? Then there are different methods. How can we extract the information? What are the different tools to extract information from the text? So we will be talking about specifically textual data today. Tools, then there are some demos, what are the implementation or the code part, then how we can use this information to construct the knowledge and consequently the knowledge graph construction, followed by knowledge graph representation and embeddings. So I'll first start with the couple of ingredients. So whenever we want to extract information, what we want some data, right? And data could be in form of text, in form of image, video, speech, anything could be data, right? And now if we want to extract this information, some sort of, so if we have some text data, then we can extract information from it. If we have these images, then looking at the image, you can generate some sort of text. So suppose you have an image where a man is feeding a horse. So this kind of image, you can have a object detection module where you can detect that there is a horse, which is an animal in the image, and there is a man who is a person in the image, and he is feeding the horse. So such kind of information can be extracted from this image using couple of image detection or object detection tools, and then this information could be converted into text as well. Similarly, we can have videos, as we see all the YouTube is bombarded with lot of videos. We can take the videos from there and can extract the useful information from them also. Then we have some audio data, speech recognition systems are there already in the space. So in the so going forward, we'll start with that how we can, so what is information extraction basically in context of a text. So first of all, we have some unstructured text. I'll elaborate what is unstructured. Then we have some sort of semi-structured text. I'll also elaborate that. Feeding to the information extraction system, our goal is to generate a structured text out of it. Now, the very first term that I use is unstructured. So unstructured means that it does not have any predefined data or model. It is not organized or defined in some manner. It is text heavy. As you can see, there is lot of text on the left hand side. Then it contains some data like you can say here Napa Group is an Napa Group Tour is a organization name. Then Robe is a name of a person, our driver who is a driver for someone. And then we can have number of facts or dates or numbers which is not present here, but we could have this in the data. All sort of things can be present in the unstructured text, and there could be some irregularities or ambiguities. So what I mean by ambiguities means, let's suppose you say a word called bat. So bat refers to an animal bat, or whether bat refers to a cricket bat. So that could be the ambiguity in the text. So this kind of this sort of free-flowing text is called unstructured text. And on the left-hand side, we see that there is a semi-structured text. So semi-structured text is basically where some tags or structures, these are embedded inside the document, inside the unstructured data itself. For example, an email. An email contains some unstructured text. At the same time, it has some subject, which is subject, and there are recipients. We have CC, BCC, these all sections are there. So we have some sort of tags, but inside those tags there is unstructured text as well. Similarly, if you use Twitter frequently, then on Twitter you see these hashtags. So hashtags are kind of a semi-structured information that we have. Now our goal is to give them a structure. That is the goal of information extraction. So you can see a very nice example here that Albert Einstein, he was born a theoretical physicist who developed the theory of relativity. Now, if I have to convert this information into some sort of structure, so here this structure is in form of nodes, where these nodes are Albert Einstein, Germany, theoretical physics, theory of relativity, physics. These are all the nodes, and there are edges between them. So you can consider them as a graph structure, form of graph structure or tree structure, where Albert Einstein and Germany, these are related with an edge called born in. So that convey us the information that Albert Einstein born in Germany. Similarly, Albert Einstein and physicists, they are linked with an edge called occupation. Then consecutively developed with an edge developed, and this theoretical physicist is a kind of physicist. That's the information, and physicist is a physicist always practices some physics, which is a branch of theory of relativity. A theory of relativity is a branch of physics. So this kind of information, we have structured them in form nicely in a form of a graph, and you can call it a heterogeneous graph. So if you are aware of the graphs, then there are two kinds of graphs where we just have a nodes and edges, but there are no information which is present on the edges, and nodes are of similar type. So let's say if you have heard of social media graph, social network, we say Facebook is a social network. So on social networks such as Facebook, we always see that that there are people as a nodes, and those people, yeah, Doctor
Please go ahead.
Shashikala.
It was a noise.
Yeah. Okay. So, Dr. Saika, if there is anything in the chat, you can tell me. I am not looking at the chat box. If someone has the query, or he or she can speak, unmute and speak. Okay, so yeah, so I was talking about the social networks, and social networks, we have all the people as the nodes, and they are connected with whether they are friends with each other or not, at least for the Facebook I am talking about. Now there are also a network between them that is a form of a graph, but that is a kind of a homogeneous graph where the connections are only when there is a some sort of friendship between them. But here, if you will see that there are different kind of connections between the nodes, and there are different type of nodes as well. So Albert Einstein is a kind of a person, Germany is a location, physicist is a designation, and so on. So I'll elaborate it more in the upcoming slide. Let's move to the first. What are the challenges when we want to extract such information from the text? So if we want to extract such information, there are a couple of challenges. The first challenge is the heterogeneous data. By heterogeneous data, we means that we have data from different sources. There are different kind of industries, business areas, languages, labor market, educational systems. So if you are working in a medical domain, you have a medical domain data. If you're working in some financial domain, you have finance data. And if you're working in sales data, and so on. So different kind of heterogeneous data is there. Second is unavailability of domain specific concepts or the knowledge bases. So this is the second point which I'll discuss in brief. So what I mean by domain specific concept. So right now we talked about this medical, financial, sales. These are the different domains. So if I talk about the word doctor, so the word doctor or dr dot. So dr dot, the dr dot is for the doctor in the medical field, but dr dot is for debit in the finance field or the commerce field, we can say. Similarly, there are other concepts like if you talk about SOAP, SOAP, SOAP. SOAP is a technical term which is used in the computer science, but at the same time in the English language, SOAP has a different meaning. Similarly, we can say cell or cell. Cell is a different term in biology. Cell is a different term in context of computer networking or something. So we have these domain-specific concepts, but they are not available readily in form of a knowledge basis. Then another challenge is that we have huge volume of data, which is a noisy real-world data. And next is the scalability is definitely one of the challenges. Coming to the pipeline, how we can extract the information from our text. So there is a very nice pipeline, cleaner pipeline that you will see here. The first is that we have a lot of raw text that we have, and then we apply a sentence segmenter on the top of this raw text so that we can so if we have a very nice document, we have a lot of paragraphs in the document, and then those paragraphs are made from some sentences. So now if we want to segment the sentence, want to see that what kind of how many sentences are present in this paragraph, then we can use a sentence segmenter module. I'll show you that what kind of sentence segmentation modules are present. Then inside the sentences, we have a lot of words, which we call as tokens for now. So word tokenization, now this sentence need to be split into a couple of words. That is a word tokenization. After that, we have this part of speech tagging, and elaborate that this in brief that we want to capture some sort of grammatical structure in the text that you can use to tag each of the word with some label. This is called as part of speech tagging. I'll also elaborate the tools for part of speech tagging in the upcoming slides. Using this part of speech tagging task, we can do NER task, that is named entity recognition task as well. Now, collectively, all these tasks lead to another task, which is syntactic parsing. So by syntactic parsing, we mean that all the segmented, tokenized, and the part of speech tag kind of entities, these are assigned some relationship between them. We assign some kind of relationship between these tokens by some kind of syntax rules or the grammar. Then we called it as syntactic parsing, and on the top of that, co-reference resolutions. So co-reference resolution, I'll quickly jump to how you can understand this co-reference resolution and how both of these tasks can be used for entity disambiguation and relation event extraction. So let me go to the let me go to some. Okay, I can't use my browser. Yeah, I can use it. If I go to Narendra Modi, let's say Wikipedia, okay. So you can see here that I have opened Narendra Modi Wikipedia page, and can anyone tell me that what are the, do you see any sort of unstructured text or structured text here? You can unmute or speak. No one?
The participants can even unmute the mic and speak, please.
Yeah, I hope you guys are on board with me.
I think that everything is
Yes,
unstructured
Vandita, very.
except the one wherein we see the photograph along with this information. I think that could be the structured one. And I
Right,
have one more
right.
question.
Very right. Very right. Yes.
I have one question also. I could not understand that term named entity recognition, which you mentioned in the previous slide. What is that?
Yeah, so I'll come with the details of the named entity recognizer in the upcoming slides. So that was a brief overview of the topics that we want to cover in the IE pipeline. So I'll come up with the details and the demo in the upcoming slide. Yeah.
All right.
Okay, so very right, very right. The right hand side, you see the structured text, and why it is structured, it has some sort of categories, which we call as properties or the relation, like president, and then this vice president preceded by, these are all the structure that is present. And on the left hand side, you see a lot of unstructured text. Now, what I want to point out here is co-reference resolution part, which is a very small part. Now you see that Narendra Damodar Das Modi is an Indian politician. This is written. Then it is written he was the chief minister of Gujarat. Now here he refers to this Narendra Damodar Das Modi. Similarly, wherever the upcoming or unconsecutive occurrences of he is there in the text, then all the he refers to this Narendra Damodar Das Modi. So the mechanism by which we identify these all the occurrences of pronouns are referred to which entity. That technique is called as co-reference resolution, where we want to find the reference of these entities. So that was the briefing. Now I will be continuing with each of the module that is being shown here. So first of all, we have a raw text, and I'll just elaborate that if we have so I'll talk about the real world data. So in the real world data, we have a lot of unstructured, semi-structured, and noisy text which is present. Now, how we can use natural language processing techniques on the top of that. So in very brief, I'll say that we can employ a sentence segmentation or a detection module. So there are different kinds of module which are present in the space. There is a library called Spacy, which is having a detection module. It can detect all the sentences. So these are the bigger systems which are being trained on a lot of data, where they are trained to recognize that if you have some sentence ending with a full stop kind of patterns, they learn where they are easily able to detect the sentences. The second is that we have a lot of HTML or non-ASCII characters which are present in the text. Then we have to remove these kind of characters from the NICE data. Third, we can exploit some rule-based heuristics. By rule-based heuristics, I mean that if you find some patterns in the data, so let's say a lot of people, whenever there is a user-generated text, user enters some text, so you use social media very frequently. So social media, you use different spellings for the same word. You write what, WHT, what, WHAT, sometimes WT, and something like that. You refer to different kind of spellings. Then we have some sort of patterns. Patterns in the sense that whenever you have some email ID, then it is always followed by some @ and domain name, and before that you have some name, and it could contain any characters from A to Z, 1 to 9, or special symbols as well. So, so these kind of patterns are present in addresses, emails. What if we have all sort of things in the unstructured text? Then you have to use some rule-based heuristics to infer that information from the text. Then you have to deal with the abbreviations. So abbreviations, as I said, dr.doctor or DOCT or r-doctor. There's some short form like NIT, NITKUK, and the bigger name is National Institute of Technology. So these are the abbreviations that we have to deal with the structured and semi-structured data. Now I'll jump to the module that how we can extract these kind of structure or keywords from this data set. So I'll show you that there is this library called FlashText. So this is a very nice library. I So I've jotted down the links on the on every slide so that you can see. So flash text is just library where if you want to extract the keywords from these sentences, then there is a flash text algorithm. So how we can use that? So you can see here that we just need to import an library called keyword processor, and whenever you call this particular library, make an instance called keyword processor. You just need to pass two names. So let's say if you have a name called Big Apple and you want to standardize it with New York. So let's assume a example here as, let's say you have an unclean name called NIT KUK and you want to replace it with National Institute of Technology Kurukshetra. So you can add your first name here, the second name here, and then whenever you have some sentence, I love, so I study in NIT, KUK, and let's say Bay Area, then it will extract the keyword as National Institute of Technology, Kurukshetra, and Bay Area. So you can have an unclean name or the standardized name pass through this library, and then you can extract the keywords. Similarly, you can replace the keywords, like if you want to replace New Delhi with the NCR region in your text, then you just pass a sentence and it will replace you with the NCR region. So this work could be done with a simple replacement find replace function that we usually found in text or Excel, but whenever you want to do it on a very large scale data, you need some programming language to do this task. Then there are some case sensitive example where we have Big Apple and B is small in the text. Then you want to you don't want to extract this smaller Big Apple, the small B big, but rather you want to extract the case sensitive thing. So therefore you can define case sensitive as true, and then you can extract this Bay Area from this. Similarly, you can also find the span of the keywords which are extracted, and I'll not go through other examples of it. So this is the link. I can post it in the chat as well. And so where should I? Yeah. Is it there? I can't see the chat. Okay. Let me then share the slides. You can extract it from here. Okay, so next is how, so after keyword extraction, so once the data is pre-processed, then we jump to the next module, that is the entity extraction and the entity extraction, relation extraction, and triple extraction. So first of all, I'll tell you what are the entities, relations, and the triples, and how we can extract the entities. We will then look upon the different tools named entity recognition systems which are present in the space to extract the entities. Yeah, so the entity extraction, so by entities, we mean that, so we have a lot of concepts or the objects that are present in the space. So I specifically work in the recruitment domain, therefore I have taken example of some recruitment domain entities here, but you can take example of any kind of entities to understand it. So what I'll say is that there are a lot of institutes which are present in the space, institutes, qualifications, there are skills like Python, Java, C, C++, then there are different salaries. We have different type of recruiters, whether they are some consultancies who are hiring or they are MNCs which are hiring, or some Indian companies. Then we have different locations. There are duration for which we have certain job for there are different shifts for different person. And then we have type of candidate, male or female, type of candidate that is required for a particular job. So these are the different entities that are that you can say are linked to the recruitment domain. If you talk about the medical domain, then the entities could be the name of the drugs, the doctor names, the different kind of hospitals that are there in the space, and then pharmacists and appliances. Appliances and then diseases name. So these are all the entities for the medical domain, and so on for the other domains as well. So why we call it as entities and not just words? Because these are the concepts which are defined in the real world, and in order to identify these kind of entities, you need some kind of POS tagging system or named entity recognition systems. At the yeah, we see that how we can use these kind of systems here. So I'll just go to the demo of Spacy. So we have this library called Spacy. And you can see here that we have a text, we have entered. So this is by default text which is present here. On the left hand side we have some text which is present, and you have to just you can just unclick them, and on the right hand side you can see there are different languages that you can choose. This is the English language. So we have choose English language model. So this is the pre-trained model that is present with the Spacy itself to parse the English text. Similarly, there are different models for the different languages. Around 12, 13 languages are models for 12, 13 languages are present here. The next step is you can just run this system. You can just run this system, and whenever you just press enter, you can see here that this tree is being constructed here. Now I'll elaborate that. You can see there are different words in this text. So Spacy uses JavaScript, then SVG and CSS. You can see here that it is a proper noun, which is Spacy. Then this is a verb. So these are part of speech tagging. These are the tags which are provided by the model. So this model is being trained on a very large corpus with a lot of annotations, where you have this trained model. You are just using this trained model to extract these kind of tags from the sentences, and these are called as the part of speech tags. So you can see S, which is again proper noun, and then this is coordinate conjunction, and is the conjunction, then proper noun part. Show is the verb, and then how adverb and computer noun, understand is verb, and then language is noun. So these kind of part of speech are present. So this is one of the library, Spacy, which can help you to extract this part of speech tags. Similarly, we can see our next module, which is the named entity recognizer. So named entity recognition, it is the task of extracting the named entities, the name of any entity. So you see a paragraph here, and you just enter this paragraph. Out of this paragraph, you get all these kind of entities. So I can also run this particular system, that how this. So this, for now, I am showing the demo for the Spacy library. There are other libraries, other tools as well for doing the same task. So this is for the Spacy itself. So you have a paragraph here, then you choose this model. So this is an English language paragraph, therefore you will choose the English language model. And then you can check box here what kind of entities you want. If I uncheck, you can see that I'm just losing these entities from the text. So this is the text. If you need to find out that I want to find out person from this text, then this named entity recognizer tool will identify the Sebastian Thrun is a person which is present in the text. So we call it entity because it has a certain type called person, and there is also an instance Sebastian Thrun linked to it. Now, if you want to just extract organization, then you can see here the throne is the organization which is extracted. Then if you want to extract some date, then you see that 2007 it marked it as date, although it's a part of a date, that is a year. Earlier this week is also marked, that is a date, a decade later marked as a date. So it is very nicely able to understand the English conversions of the date as well. And then also it marked the Google as an org. So why is Throne marked as organization? So it is marked as organization, the kind of training data it has. So it is a person. We know that it is a person, but the kind of model they have trained it recognized it as a organization. So this is one of the false positive that is here due to the kind of training data that the model is being trained on. So these models are not always 100% accurate, and I'll show you a lot of examples where these models fails and how we can improve these kind of models to whatever domain we want to fit in. So this is a system where we can choose different, if you want to choose language, then there is no language present here, or percent money, you can see cardinal is a number, then dozens is extracted from the named entity recognition, and if there is some quantity present, then you can extract it. Moving to the next module, that is how to use Spacy NER, then we have this simple code. This code is, I hope some of you came across the Python language. This code is in Python, but there are different languages where you can use to call this Spacy library, but Python has a nice support with the Spacy. So we have imported these libraries, NumPy and Pandas, then Spacy library. To further on just load this model. So right now we have seen the web interface where it was loading the en.core web SM model, but we can also use the programming language to just load this model and pass our file into it, and then it will mark us all the locations or GPE or organization or the person, whatever you want to extract from the text. So someone asked the question about NER. I hope it is something clear from the previous slide. If not, we can discuss it again. Next, moving to the next part, that is the dependency parser. So dependency parser is again a kind of tree, you can say, or dependencies, how we can extract the dependencies between these kind of tags. So using part of speech tagging, we extract these tags called proper noun and verb, proper noun, but what is the relationship between them? So that is exhibited by the dependency parser. So you can see that verb and the display seat has a relationship and subject. So it's a subject for this particular verb. Similarly, this SVG is linked with the conjunction, and then it is it has a relationship CUNJ with the CSS. So these kind of relationship, they are defined in the Spacy documentation itself. You can go look at spacy.io, where they have provided a very nice documentation that what are the meanings of these relationships here, and what these mean by DOBJ, CONJ, and SUBJ. So you can, the documentation gave a very nice explanation of each and every relationship. So this is how the dependency parser looks like. Now, once so you have seen till now, you have seen that we have extracted all the entities using NER, and then we have done POS tagging, dependency parsing. Next, coming to the part of relation and triple extraction. For relation and triple extraction, I'll say that there are systems in the space which helps us to extract the relations and the triples from the unstructured text. Now, these kind of systems are called the open information extraction systems. So, why we call it as open information extraction? So, information extraction was fine, converting the unstructured or semi-structured to the structured. But by open, we means that we have to do the extraction of relation tuples or the relations, binary relations. But relations, they do not need to be specified in advance. We don't want to specify them. So given some sort of unstructured information, you want to convert it into the form of relation tuples, where you have a relation in the center, and then there are subjects and objects as argument 1 and argument 2. Now, the only primary difference is that these kind of OpenAI systems, these are unsupervised. These are unsupervised. You just need to pass the text through them, and it will help you extract the relation from that text, irrespective of your domain, whatever the domain of text you are providing. So it is domain independent in this sense. Second, this is ontology free. So yeah, the ontology part Monica will discuss about in detail. Then these are also scalable. So you just need your corpus and some existing sources as an input, and it can discover automatically the relations out of it. And you do not require any annotation of the data. So by annotation, I mean you don't need any labels for your data. So that is the advantage why OpenAI approaches. These are the advantage that you avoid hand labeling or the annotation, single pass over the corpus, then there is no pre-specified vocabulary. Now I'll discuss what are the different OpenAI tools that we have and how you can use these kind of OpenAI tools to extract the information from your data. So I'll quickly first go through the very first tool, which is Reverb. So Reverb is an OpenAI tool which is identifying relations for open information extraction. So Reverb was one of the research that was done published back in EMNLP 2011, and EMNLP is one of the premier conference in the computer science field, where all sort of natural language processing works are being published. This was the research by University of Washington, Seattle, back in 2011, and this is one of the nice information extraction system which helps you to extract free relations from the free running text, and these kind of relations were better than the previous very basic OpenAIs like text runners and all. So on the right hand side, you see a snapshot of the paper, and then there is link which is provided. I'm not going to open the link since Reverb does not provide a web interface. You need to download the dataset of Reverb, and then you can run it using your Python or R code, whatever. The second tool which we are having for open information extraction is the Stanford tool, tool by Stanford University. So yeah, this has a web interface. I can go to the tool to just show you that how it looks like. So this Stanford Core NLP framework, it does not only have an OpenAI as an option, but you can see here the drop down. You have the named entities as the option, then you have OpenAI, then you have co-reference, relations, then sentiment. So you can choose multiple options, whatever the task you want to do. And the example that we have seen, that Narendra Modi example, where we want to do the co-reference resolution. So you can just select the co-reference category here and can resolve this particular, do the co-reference resolution part. So similarly, you can just add, let's say, Obama lives in USA. I have this sentence where we enter this sentence and just submit it. So it's running a little slow because I have choose a lot of categories here. We can just we can just remove some of the categories so that to help it. Let me just rerun it. So this is a little, So when we run this tool, you can see that it has done part of speech. So part of speech was initially, we have seen through the Spacy library. So this library, Core NLP framework also support this part of speech thing. Then named entity recognizer, it recognized Obama as a person and then USA as a country. Then we have a dependency parse tree here. So basic dependencies, then there are some enhanced dependencies. And the main part that I want to elaborate here is the Openle. So you can see here that there was a sentence, Obama lives in USA, where USA is an entity of type country, Obama is an entity of type person, and there is a relation between them, which is lives in. So this is the triple, you can say Obama, lives in an USA. So this Openle worked well for this particular sentence. So this was the generic sentence that was input to this. Yeah.
So in the construction
Hello?
of this, am I audible? Am I audible?
Yes, I can hear you. Yes.
Yeah. So my question is that in the construction of the dependency parse tree, I mean, which all production rules are being used? Can we see them? Can we see the grammar through which the dependency parse tree is being generated?
Yes, we can definitely see the grammar. So what you can do that, so dependency parse tree, while building the dependency parse tree, there is a lot of training data that we have, and we have a lot of annotations for each of the. So whenever we have this sentence in the training data, Obama lives in USA. So these kind of sentences are annotated with the uh, with the labels, subjects, and whether they are noun phrases and different categories. So based on that annotation data, you can train these kind of constituency parse tree, dependency parse tree, and later on, once the model is trained, you can use them. So if you want to see the grammar exactly, you
Please continue.
So if you want to see the grammar, go ahead.
Yeah, so I view this training part as similar to the process of, say, tokenization, which we use as the very first phase in the compiler design, interpreter compiler design. We go for the lexical analysis. And once the tokens are ready, then we should have a set of the rules to generate the parse tree. So therefore, I asked this query that, how can I see the different rules through which this dependency tree is being generated?
Yes, so you have to define these rules in your data itself. So whatever, so you have different kind of dependencies, right? You can have semantic dependencies. You can have morphological dependencies where different forms of words or part of words are there. So depending upon what kind of dependencies you want, you need to provide that kind of annotated data to these kind of labels. So there is a whole research you can, so I'll suggest you to go to the this Stanford module, Stanford Core NLP module, where they have given a detailed explanation for how we can have this pipeline for dependency parsing. So you can see here on the left hand side the lemmatization, the dependency parser tree, where you can see that it provides a syntactic dependency parser and they have an annotator class name. So these are the different annotation categories which are present here. And you can just jump to the code. They have a GitHub library as well. So they have provided this page and the documentation here, where you can find this. So this is the whole code is written in the Java language, and there is a description, options, and how you can train a model on the top of that. So I'll suggest you that you can go to this particular link. Yeah, I'll add this link in the slide as well. So whenever I share the slides, you can access that. Okay. Does that answer your question?
Thank you.
Okay, so the next tool that we can look upon is the Stanford OpenAI tool. The Stanford NLP OpenAI tool. And since we are running short of time, so I'll not just run the demo, but I have a link here in the slide. You can just go to the demo and it show you the OpenAI similar fashion the Stanford runs. So this is the example where it extracted the argument 1 as Albert Einstein, a German theoretical physicist, and the verb as the published, and the another argument as the theory of relativity. Then the next is the in 1915. This is a temporal argument that it input from the text. So we can say that it extracted the triple argument 0, verb, and argument 1. In addition to that, it extracted the context as well. Then there is another OpenAI system, which is ClauslE. ClauslE is a different form of system. This research was done by Max Planck Institute, Germany, and it was again published in a very premier conference, that is WWW13, which is one of the great conference in the computer science field. And it is different from the previous tools that it exploits the linguistic knowledge about the grammar of the English language to first detect the clauses in the input sentence. So the previous approaches, they were unable to detect the clauses, and depending upon each type of clause in the sentence, they each clause, according to the grammatical function of its constraints, it identify the type of each clause. So ClauslE also has a demo. So I have put here some of the extraction here. So I'll first tell you that after ClauslE, we have another tool, which is OpenAI 5. And OpenAI 5 is also readily available. It is by Professor Mosam, who is a professor at it's a professor at IIT Delhi, and he has done his whole research in the OpenAI field, open information extraction field. So if whenever you hear about OpenAI 5, OLI, OpenAI 4, so these are all the different versions of the OpenAI tools that he developed while he was a part of University of Washington. Yeah. So this is one of the examples. So yeah, you can, so we have all the links in the slides. You can go to different OpenAIs and run your data there. But I have added this comparison in the slide that the reverb, OLI, and the ClauslE, the basic difference is that whenever we have some clauses in the sentence, so there is a very large sentence, you can see that OLI. So OLI is just the predecessor of the OpenAI 5 by Professor Mosam. So this system, it extracted this kind of triples from the text. He fathered 2 children. He lived Aberdeen. He lived until his death. And then ClauslE system, it is able to identify also he lived in Aberdeen until his death. So this kind of relationship he captured. His death. So his, again, you need to do the co-reference resolution here, but his death is one of the correct triple that could be extracted. ClauslE, you can see, extracted a lot of triples from the text, whereas Oli and Reverb, they missed the triples like he fathered Edna and Donald. So coming to the next part of it, what are the challenges that we deal with these kind of OpenEyes in the domain specific scenarios? So these are the general things that I talked about, how we can use these OpenEye systems for our application. But if we have a domain specific application, so there are different challenges. So first challenge is that there is no triple generation. No triple generation, we mean that if you don't have a well-formed sentences, you see that here everything depends on the grammar or the sentence grammatical structure. If you don't have a good sentence good grammatical structure for your sentence, let's say you have incomplete sentence, drug discovery knowledge required. So in these kind of sentences, you will end up with no triple. Similarly, you have a imperative form of sentences, please carry your updated profile. Then there is no triple extracted. Then non-verb relations where verbs are not present. The possible reason is that these kind of models are always trained on some kind of rules, for which they want a perfect organization, syntactic structure of the sentence in order to perform well. Then there are some complex sentences where you can you end up getting no triples. Then the second problem or the second challenge in these kind of systems is that if you have a sentence experience in aircraft, similar sentence like this, you are able to extract this kind of triples, 0.89. So here 0.89 and 0.80, these are just the confidence scores which are written by these systems. When you run OpenEye 5, you can see there that with each of the triple, which is cables will be plus, you see a score, which is the confidence score, that how much confidence it has that the triple is correct. Then you see here that it missed that experience in aircraft norms is a plus, should be extracted from the text. So this is an incomplete example of incomplete triple generation. Similarly, you can get multiple triples from this OpenEye, and later on incorrect triples. Why incorrect? That if you have a sentence that freshers can apply but not from 2017 batch, then OpenEye system end up extracting it like that. Freshers can apply and miss the other part, just due to the fact that these kind of sentences are not a part of the training data of these kind of OpenEye systems. So in the domain specific scenarios, to sum up with what kind of challenges are there, so if you want to use these systems for your application, you can merge 2 or 3 systems which perform well for a specific kind of scenario. So like Stanford OpenEye, they perform well for single sentences, not for the compound and the numerical things. And the compound and the numerical things, you can use OpenEye 5 like tools, and then ClauslE tools if you have more clauses in your data, more complex sentences you have. So depending upon that, you can use a combination of these OpenEye systems so that you will be able to extract better triples from your data. Yeah. So now ending up the information extraction part with the OpenEye, and there is one another subtask which is called as template filling. That given a paragraph, you want to automatically generate a report. By report, I mean that you have a template that there is an event called earthquake, date, time, magnitude, location. So these kind of information you want to extract from this text, but you have this template defined in advance that these are the entities that you are looking for. Then template filling is the task of extracting this particular template from this, and you can make a very nice entity graph from this template filling task. Then it is followed by event extraction. They are more or less sort of same because we have extracted the events in the previous task as well. So if you have a text, you want to extract the event from it. So university admission is one of the event, and it has a property called property, which is university, MIT. Then engagement is an event, and Kyalato is the property here, and so on. Yeah. Now, how do we move from the title of our talk was the knowledge extraction? How do we move from information to knowledge? So far, we have seen that we have extracted the information from the structure, from the unstructured text, semi-structured text. Now we want to convert it into knowledge. This is the machine readable or machine interpretable format. It just goes one step beyond the information, that is, if we can make the use of some existing formal knowledge or the ontologies, or we give some sort of schema to this data, then it can be called as a knowledge extraction task. So far all the information is extracted, arranging it some way, call it as a knowledge. Now we have seen all these tasks, and then I'll quickly elaborate what is disambiguation and linking part. So ontology part will be covered by Monica. So this is the overall pipeline that we have seen, that we have pre-processed the data, then we extract the information. Then there is a polarity and context detection part, which means that so this is a very brief part, and it depends on the kind of the data that you deal with. So since I work with the recruitment domain data, and in that kind of data, it is very important to capture the polarity. So by polarity, we mean that if someone wrote that we need no experience required, let's say no experience required is written for some kind of job posting, then I want to extract experience as an entity, but at the same time the polarity is negative for this experience entity, where it writes no, I don't need any experience. So it is important for our platform that we want to capture such kind of negation modifiers as a dependency and the context of the entity as well. After following all these parts, we construct our knowledge graph on the top of that. So what is a knowledge graph after extraction of all the knowledge? In simple layman term, we can say that, the knowledge, it represents a collection of interlinked description of entities, events, or concepts. So we have seen that we have extracted triples from the unstructured text. And this kind of triple, if represented as a nodes, and then H is the relationship between them. So Narendra Modi is Prime Minister of India is the text, where Narendra Modi is a kind of politician or a person. And then India is a, Pankaj, what's your question?
Yeah, but in this case, even the Prime Minister could be an entity, and say the India could be the relationship. So, I mean, who could resolve this kind of the ambiguity in the construction of the entities and the relationship among them? Like, say, it could be like
Yes.
this, that
So,
the
yeah,
Narendra Modi is the Prime Minister, but he's the Prime Minister of India.
Yes. So can you come again? What are you saying that what it should be, how it should be the another way? What should be the node?
So my point is that instead of India, Prime Minister could be the another entity, and the India could be the relationship. If I'm using the correct term in between these two entities. So Narendra Modi is one entity, and then Prime Minister is another entity, and India could be the relationship, implying that Narendra Modi is the Prime Minister of India. So there could be different
Right.
interpretations of the entities and the relationships in a paragraph. So how do we resolve such ambiguities while constructing the knowledge?
Okay. That's a very great question. That's a great question. And so how do we resolve such kind of ambiguity? So whenever you want to construct a knowledge graph, you need to define what kind of entities you want. So here, if I have taken example of Narendra Modi as an entity, India as an entity, where I have put the Prime Minister as a relation. So I have defined that I want the location, all the kind of locations as the entities, and the type of persons in my data, person in my data as an entity, or any organization name as an entity. So what kind of entities, what types of entities I want for my data, that I need to define in advance. And similarly, I want to define that what type of relations I am looking for. So the example that you gave is perfect. That could be a knowledge graph. So I would say that is a knowledge graph which is just represented in a different way, where your relations are different from what kind of knowledge graph I have. So there could be multiple knowledge graph for the same data. It depends how you want to represent it, what kind of classes, entities, relationships you are looking for.
All right. So do we use
Does
some
that answer your
kind of
question?
framework? Yeah, thank you. So do we use some frameworks, or I mean, how do we construct the knowledge graphs with the help of existing frameworks, or how do we develop them?
Yes. So so far we have seen that we have OpenAI systems which can extract triples from the unstructured text.
Mhm.
So for construction of knowledge graphs, you need to have triples first. Second, you need to define schema. By schema, I mean the ontology part, which Monica will cover. So it's a description of all the classes, relationships in the data, whereas triples are the instances for that data. So these kind of OpenAI systems are quite popular to extract the triples from the unstructured text. Similarly, you have different deep learning models which act as a relation extraction tools, where you can extract different relations from your text. Then the third thing is, if you already know, sorry.
Yeah, there was a noise. Please continue.
Yeah. So the third thing is that if you already know that what kind of relations you are looking for. So let's say you work with a company which have different products, which sells different products. So you already know that these are the products which people or any customer, they co-buy together or co-view together. So let's say bread and butter are two things which people frequently buy together. So such kind of data you have, and you already know that there should be a relation called co-view between them. Then you have such kind of, you can define your own relation. So this is called as closed relation, we say. So for now we see that using OpenAI, we have all the open relations, or the different relations that the OpenAI extracted from the text. But you can also have this sort of closed relations where you can define your own relation to construct the knowledge graph. So there are no, so to say, one end-to-end frameworks. So there are a couple of frameworks which are provided by different industries. IBM Watson is knowledge graph, which have different modules to extract all these kind of entities, relationships. But that definitely it's a data-driven approach. What kind of data you have, you need to use all sort of heuristics, combine them together to construct the knowledge graph.
Madam, I have a query. May I?
Yeah.
Hello. Madam, actually, I have a query. Whenever this construction of knowledge graph, so what the discussion we had, it seems that we are trying to use either the linguistic knowledge of the English language, or might be the syntactic features of the language, the way the parts of the speech and all. Can we incorporate, or can we use some semantic knowledge also? Like especially for dealing with a very large document. The area where I'm dealing with is legal document analysis, which is too lengthy document. So is there any kind of semantic technique or semantic knowledge we can use for the construction of the knowledge graph?
Yes, can you define what kind of semantic knowledge, what type of semantic knowledge we are talking about?
Madam, like if you are saying that like every sentence, then verb is a relation and the name entities, they are basically representing the nodes. So this is like a abstract level. So if I'm dealing with a very lengthy document, from every sentence, this like the entities triplets will be created. Maybe many of them can be a redundant one also. So in that case, if I want to represent a document as a whole in the form of a knowledge graph, then can there be some kind of filtering can be applied with the help of any other technique?
Yes, yes, you can define different semantics. So you need to define those semantics, what kind of semantics you are looking for. So for an example, you have a very large document and it says that let's say you are eating with a spoon or something like writing with a pencil, then these kind of phrases where you have a pencil and spoon, so these are the different instrument that you are using, and they have a different so the category would be the instrument, but they have different semantic roles uh, that you have in the document. So that's how you can define your own semantic rules or roles, whatever you are looking for the domain specific scenario.
Okay, so like that, if I have predefined relations, or that means some relations which I am interested into, and others the information need to be filtered out, because if I am dealing with multiple documents of this scale, then in that case it becomes difficult now to maintain such a lengthy knowledge graph for every document.
Yes, yes. So it would be difficult, but there would be some facts which would be present in all the documents. So let's say you have a lot of news articles. Then
Okay.
some of the news articles, they may talk about Obama, or some talk about Narendra Modi, and some talk about other political persons. So in all the documents, you may find certain entities which are part of all the documents, or some of the documents at least. So from there, you can define your nodes as those politicians. So let's say Obama, there are some facts. So here, what you can do here is that you can define your entities as Obama, and then all the connections which are linked with the, or the relationships that are linked with the Obama can be extracted from all the documents. So
Okay.
that's how you can have a graph between two nodes and define the relationship between them.
Okay. Thank you very
Yeah.
much, ma'am.
Okay. So I'm moving ahead with, so we have less time. Yeah. So I'll quickly cover this part that we have couple of definitions which are present. You can look to this paper which is published in the CUR workshop, and there are different definitions which are given by Pujara, Journal of Web Semantics, Semantic Web for the knowledge graph, but the underlying meaning it remains same. And now a very brief idea of why do we use knowledge graphs. The simple explanation is that we want to connect each of the entities or the words around in space uh, uh, in form of entities. These are not just things. So here Narendra Modi is just not a word. We have defined the real world meaning to it, attached the real world meaning, that is politician to it. So that's the, and whenever we represent some data in form of graphs, then it could be we can manage uh, uh, complex representation, and graph are easier to process. And if you look at the Gartner hype cycle, it says that graphs are on the hype for the next at least 10 years. Different graph databases are evolving. All the industries are shifting to the graph database just because so that they can extract the connections between the content. Then I can quickly show you that what all are knowledge graphs present in the space. I hope a couple of talks have already covered it, so I'll not go into the detail, but I have added the snapshot just for the sake of simplicity, that knowledge graphs, Go, DPpedia, Freebase, Facebook, Google, NEL, these are all the knowledge graphs which are present in whenever you search for search on Google, who is Prime Minister of India, you see the answer Narendra Modi, that is extracted from the knowledge graph itself. And on the right hand side, you see a knowledge panel, which says all the structured information, extract all the structured information about Narendra Modi. Then DBpedia was published back in 2012. I tell you that Google coined this term as knowledge graph in 2012. Before that, knowledge graph was, so there was whole semantic web field, which which evolved long before, but formally knowledge graph term was coined by Google in 2012. Then DBpedia is also one of the knowledge graph, which is extracted from the Wikipedia itself, and it's a multilingual, lot of languages are present here. So I have added all the links so that you can just go to the link over the slides. Wikidata is also knowledge graph. Go, Openle, Freebase, product graph. So these are all the. So here I can summarize what I worked during my PhD in the first phase. So I worked over the construction of these knowledge graphs. I specifically worked over construction of the recruitment knowledge graph, where we followed this pipeline of data pre-processing, information extraction module, construct the ontology, and then use the graph database Neo4j to store this knowledge graph. And we end up publish this as a short work in ACM proceedings, ACM Hypertext 19, Con2kg large scale domain specific knowledge graph, the conference held in Germany. So takeaway from this knowledge extraction approaches, the quick takeaway is that these knowledge extraction approaches, they vary from manual to semi-automatic to automatic, including statistical methods, relational ML, new facts, edges. Then always, so you can't say always that my knowledge graph is complete. It's always incomplete. It may have some errors. It is incomplete, incorrect. And the correctness also depends on the temporal validity as well. So right now, Narendra Modi is Prime Minister of India. Maybe whenever the next election happens, he loses the election and someone else is the Prime Minister of India. So these are the relationships which temporally keep on changing. So we should have some kind of temporal data associated with it, so we can update it periodically. Next, I'll just end my talk with the last part, which is the knowledge representation part. Knowledge representation part talks about that once we have a knowledge graph, how we can represent this knowledge. So how we can represent this knowledge. So let's say a simple example, Mary and Tom are siblings. They both are vegetarians. They work in Amazon, and colleague Mary and Tom. Then if you want to have a symmetric relationship, then you can say that Joe is colleague of Tom and Tom is colleague of Joe. This is a sort of symmetric relationship that is there. Similarly, you can say that Quebec is located in Canada and Canada cannot be located in Quebec. That is an anti-symmetric relationship. So these kind, once you have all the knowledge graph, then if you want to represent these entities and relationship in the space, so there are these couple of tools to represent knowledge. So trans is one of the method which was devised in 2013 to represent this knowledge, where we have this triple and you have a vector, head vector, which is the subject vector, then you have the relation vector, you add both of them, and then you can reach to the tail vector. So the end goal is to represent this triple effectively, in the sense that you can just cover the whole entity. You can represent these entity and relations very well in the space. So these are a couple of libraries that you can explore for knowledge graph representation or knowledge graph embeddings. Ampligraph, PyKin, OpenK, LibKG, these are all the libraries. So yeah, you can just go to these libraries. Thank you. Any questions?
Thanks, Ms. Nidhi. It was wonderful, and I could see that the participants were interacting on the way also. Before Ms. Monica starts, a very a request in a manner that is it possible for you to provide a small prototype, a working model for the participants so that they could grow it the way they want.
Okay, you want to provide, you want me to provide prototype of what?
Maybe, for example, information extraction with a which can work upon a very small text.
Okay. Yeah. So I have
Maybe
a lot of
later
examples.
on.
Yeah. I'll share the link in the chat. Okay. There are a couple of questions. PPTs are not shared. Okay, maybe I can. Dr. Sarika, should I share?
You could pass upon the material to me so that I could pass to the participants. That is not a problem.
Okay, sure. So I'll just share the.
Yeah, on the email you could do, so I'll provide it to the participants.
Cool.
Okay, so we have to go we have next 35 minutes, I suppose. So I don't know whether it will be sufficient for her or not. Otherwise, she's again there post lunch. Yeah, Miss Monica, are you there?
Hello, can you hear me?
Yeah, we can hear you. A warm welcome to you also.
Thank you.
So,
Thank you
okay,
so
I'll
much.
pass on the presenter to you, na?
Okay,
Yeah,
sure.
I've done.
Okay, thank you. Let me share my screen. Also, I'll just a second.
Yes, it is there.
It is there. Oh, sorry. Okay, so can I switch off my video so that
Yes, please.
there will be
No problem.
just a second. Okay. So, Nidhi, thank you first of all for having me here, and I'm very honored to. And if you have any questions regarding my presentation, you can always unmute and talk to me, and you can also just write in the chat. So I would be happy to like discuss all the things. So I'll start with the motivation part. So Nidhi talked in detail about the extraction part, in which she talked about how to extract the entities and how to extract the relations from the libraries, like the Spacy library. You can use various applications. She also explained about the Openle tools. So, and it was all related to the unstructured text. So I hope you get it all, like how you get the text and then you extract the entities and the relations from that and you construct a knowledge graph. So I'm going to extend this presentation by that only. So firstly, I'll give you the small demo of the code because what she explained is the application part in which we use the libraries and we connect the knowledge graph. But how to do it from the scratch? Like there were some questions regarding the grammar. There was questions regarding how to construct a knowledge graph with respect to their domain space. So that is why I thought of like giving a very short demo, like how to create your own knowledge graph, how to construct it. So, and I will also give the detailed explanation, like you can use other methods also specific to your domain. So, this is a very famous library called Spacy. where you can like get the parts of speech tagging, entities, and everything. So okay, so firstly what we do is we take the text and then we generate the particular parts of speech tagging for each of them. So the problem is that with these current modules that she explained, the present open information systems, what they does is they take the simple sentences like Monica is a girl, NIT Kurukshetra is a university, something like that. That's a simple, in which simple relationship like is a relationship, very simple relationship exists between the sentences. If we talk about the complex sentences, if we give some medical text or some financial text, something very specific to domain specific thing, I don't think that OpenIE or other tools can give that much information, because what they does is they have trained over the generalized document, so they does not go well with domain specific documents. So what we can do is we can like create our own code with respect to our own document, and then we can write our own features and we can create a knowledge graph as well. So I have taken a medical document. I'm working with the medical, my industry partner is medical one. So that is why I have taken the medical document. So here you can see some sentences like preterm baby are less than 28 years old. Minimum dosage of medicine is 34 mg per ml. If I take these sentences and I go to OpenIE and then I try to extract the entities and the relationship, so it is not able to, most of the time, it is not able to recognize the entities and the proper relationship. The reason is very simple, that the terms are not familiar with the tools, and also there are some units like mg per ml. There are some numerical terms also. So these are the challenges that we have to deal with for our own documents. So initially we take the sentences, we take the document, we separate them into a sentence, and then we pre-process it. Okay, so it's just removing the stop words, lemmatizing it, removing the punctuation. This is a simple pre-processing technique that you use just to like clean the sentences. After that, what we do is, like after that we have two specific tasks, like getting the entities and getting the relations, right? So for the entities, like Nidhi explained, we can use the POS tagging, we can use the dependency parser, and then we can like tag the entities. So I have used tagging tool, in which what I does is, if the particular for a particular sentence, I have divided the sentences into a multiple words. Then for every word, we check if the particular word is subject and subject pass or something like that, then it means that it is a first entity. And if the second entity, for recognizing the second entity, it should be an object. So the tagging words will be C subject pass, P object, D object, or something like that. So these are the two like particular tags from where you can like extract the entities. So if we talk about the sentence, the modern rules of many football codes were formulated during the mid or late 19th century. Here, if we talk about the entities, it is talking about the modern rules, and here it is talking about 19th football century. So here, as you can see, this is not a single word. We have the compound words for the named entities. For that, we will use the dependency parser, in which we will check if these two words are related to each other, and then we extract them. So this can be done if the particular token is compound and dependent on the previous text, then we will extract both of them. So this is the method to get the entities. As let me get clear, this is one of the method to get the entities. There are many kinds of method that you can do, but this is a very basic one that you can use for building your own system. Just to get like start with a scratch, you can do that. And for the medical entities, if I extract the entity pairs, that is the first entity and the second entity, so you can see like this is not giving that much good result. Like for the first one, it is giving a right answer. But for the second preterm baby, and there is this blank. This blank is because the object here has 15 mg per ml something. So that means that these kinds of codes that are used by OpenIE and these applications, they are not able to understand the medical document, like domain specific document, that much properly. So for this we have to use a special kind, like depending upon our own document, we have to use for extracting our own entities. For getting the relations, we can use linguistic pattern, we can use any weakly supervised technique, we can use supervised, we can use the clustering technique, depending upon all the things to the data. I have here used the linguistic pattern, in which my assumption is that the verb is present in the sentence and verb is the relation here. And that is the main assumption that generally applications take. So if this is not your assumption, and let's say there are other relations that are present in your document and you want to extract them, then in that case, if you have some label data and you can train it, you can use some deep learning models and then you can extract the relation. Or else what you can do is, if you do not have the label data, you can use the clustering part, in which you do not need the label data and you can still get the the list of the relations. So from this linguistic pattern, we can have like the various relations. You can see is less, is less. So some are giving okay values, but some are still we can improve it, because since this is the basic code, and if you will use this code for the simple sentences like Monica is a girl, this is a university, this is a baby, or something like that, this will give perfect good results. But if we talk about the complex sentences, it might work for some sentences, but for some sentences it will fail, that is for sure. Then after that, we can have, this is the other thing that I have used for the cardinality, that is not needed. So we can specify the source here, we can specify the target, and then we can have we can construct the knowledge graph. So as you can see, like this is the code that we have built, and we can modify according to our own document. So if you are there was one question regarding the large document, you can use this code, the basic code, and you can like modify it as per your requirement. So I can provide the code also, so that you can like work on it and like construct a knowledge graph and test it on different sentences so that you get an idea. So so this is just a demo part, just I thought you might be interested in. So this is like how to create a knowledge graph. So I think you already know the knowledge graph contains the source, the particular two entities, and the relationship between them. But what about the ontology? So I am not sure that you know about how to construct the ontology, like uh, through the protege or through other tools. I am not sure like you know how to create an ontology, but let me give a introduction so that it will be clear. It will be very quick so that you get an idea if you don't know how to create it. So this is a protege tool in which we can create an ontology. So what is the difference, first of all, between the knowledge graph and the ontology? The knowledge graph consists of the entities and the relationship between them, but the ontology also contains the other relationship. It can be a knowledge graph, but this is more than that. Like you can specify other kinds of axioms like union, intersection, cardinalities there exist, and only various kinds of axioms can be explained from the ontology. You can specify the vocabulary, you can specify the schema of your particular data. So ontology is very important, and this is like high level of knowledge graph. So you can use the protege tool. It is very user friendly, in which like you can click on it. If you want to create an ontology, you can just right click, add subclass, all the things are there, and then you can add it. And if you see, this is medical ontology that I have used for my research purpose. So this is for the treatment of the premature babies. So this particular ontology is being used by the hospitals in which the treatment of premature babies takes place. So so that is why I wanted to give a quick demo regarding the same. So you can see here the major role is neonate. Neonate is basically is called a premature baby. So the medical term here is a neonate. So you can see that neonate has various groups. So these groups represents the age, gestational age. If the baby is born before 32 weeks, baby is born 28 to 32 weeks, something like that. So how that's how we divided them. And then we can specify the relationship, like neonate has abdominal distension and which has some Boolean value, and a neonate has some condition which has some condition, has disease some disease. And you can check here either the value is like a string or a data type value, or it is the class value. So there are two properties, object properties and data properties, that you can specify for a particular class. Also, if you click on any of the concepts, these all are concepts. Like if you click on disease, and when you click on subclass of, then you can get the class expressions. Okay, it is hanging a bit. Okay, so you can also specify here the various restrictions type, like there exist only relations, minimum exact and maximum cardinalities are there. Then we have the disjointness, disjoint union of. So the reason for me to show this particular ontology is it is not just the knowledge graph. We can represent the concepts, the subclass of concepts, then we can represent the like other features of an particular concept, like the relationship between the two concepts. We can say that this antral feed and parental feed are both types of feed type. We can say that these are two disjoint ones. If one is having the antral feed, then one cannot have the parental feed. So these kinds of extra axioms can be generated using the ontology. But as you can say, this ontology is of good quality, but to construct one, it takes time. You need domain experts. I have not created this ontology by my own. I have contacted doctors, experts, and then they like explain me the relationship between the medical terms, and then I have created one. So you need domain expert, you need time to create manual ontology. So that is why we are actually switching to from manual ontology to automatic ontologies. So what do you mean by automatic? Like having the unstructured text like we did in the previous section, and then we create an ontology automatically. So all the axioms cannot be converted into a axiom part, like from the unstructured text to a axiom part, but still we are able to identify, as you have already seen, we are able to identify the entities, we are able to identify the relationship. But other axioms, what about the other axioms, like the instances or the other non-taxonomic relations, or we say disjointness, union and intersection among the concepts. So these kinds of axioms are for present ontology systems and for present tools. This is not been able, like till now, we are not able to recognize these kinds of axioms. So this is our goal. First, our goal is to like extract the entities, extract the relationship as per own data set. We can modify it as per own requirements. The second is to extract the other axioms as well, not only the entities and the relations, but other axioms. So I'm going to talk about one paper that we had regarding the ontology learning. So just a second. Okay, so basically creation of creation of an ontology from the unstructured text is called ontology learning. Just the ontology is called the having the entities, the relationship, and other kinds of axioms present in it. But like creation of ontology from unstructured text is called ontology learning. So this is an ontology learning cake which I will be explaining in detail in the next session. So here we can just you can like see the example here in which this disease is a combination and a union of like vision disease, union of hearing disease, and union of cognition disease, and so on. So here that this particular concept called disease is a union of these all concepts, right? So we are interested in these kinds of axioms, how we extract them, and along with union we can also extract the intersections. So these are the present systems. There are many, and they only extract the subclass relationship. So I will provide the demo for each ontology learning system in the next session. So for now, you just understand that these systems only extract the subclass relationship, but not the other axioms. And we are focusing on other axioms as well. Like I said, like union, intersection, disjointness, cardinalities, other axioms should also be extracted. And these axioms should be extracted from the unstructured text. Okay, so let's say if you have C1 concept and it is a union of three, C2, C3, and C4. It can be anything. It can be disease, symptom, cures, anything. So this is our goal. So for that, we have created a model. Like if you think about this problem in which you have an unstructured text and you have to identify the union and intersection among them. So what will come to your mind first? Like how you will recognize the union among the concepts. So firstly, you should know the concepts. Then only you will identify the union of them, right? So for that, we need some kind of like a list of concepts in which we can link them. So basically what we do is we take the unstructured text and we take the ontology, and now this ontology only consists of some candidate concepts. That means some basic concepts. Let's talk about university. So university will have the classes, university will have some rooms, and then we will have some kind of lectures, then we will have so a particular schema in which we will define that this particular class will have 10 lectures, this particular class will have this many professors, and this professor will teach 5 subjects, something like that. So this kind of schema we already defined in an ontology. So this is our ontology in which basic schema is provided, in which some concepts are already being defined. And this is an unstructured text. This is related to this ontology only, but we are like enriching this ontology with this text. For example, let's say we have taken an ontology in which the concept here is human. Okay, now from the unstructured text, there is one sentence in which it is written Monica is a human. So now from this unstructured text, I will be able to identify that human from the ontology, and Monica here is the entity which is present inside human. So that means that Monica is an instance of human and it will be added back to the ontology. So the information of Monica came from text, and I already knew about the information regarding the human. So the concepts will already be, I will be knowing them, and the enriching part will come from the text. So from the ontology, I will have the list of concepts, and from the text, I will extract the list of entities. And these entities can be extracted by various methods. Like I said before, I explained it through the code also. You can use the Spacy library to extract the list of entities. Then we will have some kind of linking module in which we will say that like Monica is a human. So in human concept, one of the instances will be Monica. So this is done by entity linking module, and after that we will have all the concepts and in which all the instances are there. Then we will find out what is the union and intersection axioms present among the concepts. So this is our detailed model in which we extract the entities from the library Spacy, and then we have the ontology. We have three separate parts. I will go through one of each of them. So first one is the bio word bank. Second is custom word to bank, UMLS Methosaurus. These are the main three parts. After these three parts, we will have the entities along with from where it is connected to the concepts. Then we will have some kind of a knowledge graph, and then we can calculate the union and intersection axioms from the unstructured text. So firstly, we will extract the entities, and we will extract the entities using the Spacy library. Then we are talking about the Wirebird back model. So this is a pre-trained model, which is trained over like 28 million articles and so nodes. So it generates the word embeddings. Word embeddings is basically a numerical form of your word. Like if you check the word embeddings of cat and dog, they will be quite similar, but something different will be there. But if you will compare the embedding of cat and table, then it will be very different. So that's how embeddings work. The words that are related to each other will have a similar like a similar kind of a embedding, and they will be close to each other, and the words which are very different will have various things apart. So this is a pre-trained model that we have used, and we have like the compared with the cosine similarity that you can use to compare the two words. So we have the entities here are extracted from the text, the concepts are from the ontology. We are finding the cosine similarity with the using of word-to-vec model. And if the threshold is passed, then we proceed to the module 2. And in the module 2, we have the custom word-to-vec model, in which we have like trained using a Gensim library, in which we generate word 200 dimension. So here, what the context words came, in which like if you have the target word pneumonia, so the context word related to pneumonia, the first 5 words and the last 5 words will also be used to get the context of the particular word. Then we will find out the word with the R entity, and if the threshold is 0.55 above than 0.55, then we will proceed to module 3. So these you might have question like how you have calculated this 0.75 and 0.55. So this was experimental basis. We have tried various values for the threshold, and after that we got these values. So this is a experimental value. After that we have the UMLS Mythosaurus. So this is UMLS Mythosaurus basically contains all the details regarding the concepts related to biomedical terms. So I'm this whole work was actually done on medical document, and this UMLS Mythosaurus contains the concepts, the main concepts like the drug's name, let's say amikacin, azithromycin, something like that, how they are related to each other. So it will be like amikacin, azithromycin are antibiotic first. So this is our first chain. Then we will say that antibiotic is a medicine. This is our second chain. Then we will say that medicine is related to medical terms. So this is kind of like we will create a tree kind of structure from this UMLS Mythosaurus. So we will have these kinds of structures using this. So you can use this if you are using a medical document, you can use this to calculate or to extract the concepts from the text. So if let's say if we have the concept pneumonia from an ontology, and we got an instance congenital bacterial pneumonia from the text. Now I want to find out whether this is an instance of this is or not. Like this entity is an instance of pneumonia or not. So the first step is very simple. Like you will find in the tree through the UMLS Mythosaurus, you will find out whether they are the direct descendant. If they are the direct descendant, if you find out they are directly connected, then you will add this as an instance of the concept. If not, then we will go to scenario 2, in which what we will do is we will like, since it is not directly connected, this infective pneumonia and basal pneumonia, and there is this the connection between them is respiratory finding. This is the lowest common ancestor. So what we will do, if there is no connection between them, we will find the lowest common ancestor between them, and then if the particular scores, like using the MetaMap, this is another library that we have used for calculating the scores between the entities. If they are related to each other, so this score will be higher. So if this particular score between the infective pneumonia and the common one, and then basal pneumonia with the common one, is greater than 0.85, then we will say that this is an instance of pneumonia. So this is how we do, like the entity linking part. So by now, what we have done, let me recap so that you are not lost. We have taken an ontology, we have taken text. Ontology consists of concepts like, let's say, person, human, hospital. Text will have a kind of sentences, unstructured text, in which we will say that Gangaram is a hospital. So now we will have the knowledge like Gangaram is a instance of the concept called hospital. So these are the entities that got extracted from the text and the concepts from the ontology. Then we have used BioWordBack. This is a pre-trained model in which we have checked the embeddings and we have checked the cosine similarity. If it is higher than threshold, then we move to this. Then we have used the custom word2vec, in which we have used the contextual information also. And then after this, we have used the UMLS Mythosaurus for linking the concepts and the entities. After that, what we will have the concepts and we will have the entities. So these are the list of concepts, and for each concept, we will have some kind of entities or instances. Like, let's say this is a human. So we will have Monica, Sarika ma'am, or Gunjan, or something like that. So some names will be there, and this is human. And then we will have another entity called hospital, in which we can have Gangaram, Leelavati, Apollo, or something like that. We can have another concept called neonate, in which we will have the baby names here. So these kinds of things will be done till here, like after the UMLS Mythosaurus step. Now what we have to do, we have to find out the union and intersection exams. Why we are doing this, why we are finding union intersection? Like I said, in the ontology, other than the entities and the relationship, there are other exams as well, which is important for the unstructured text that are not being considered till now. So we are focusing on those exams as well to add back to the ontology. And union and intersection sets are same as you have learned in the mathematical terms. If the like how to calculate the A union B and A intersection B, this is same. So this is how we have done it. Like if we have found there is two concepts B and C, and that are union of having A, then we will add them B and C in the A part. Again, if we find out other concept E union D, that is again with related to A, so we will add back to A. The same with intersection also. So this is how we calculated the intersection and axiom part from the unstructured text. And after this, we have tested this using the disease ontology, and we had some concepts one, and then we have some kind of instance relationship between them. And then after that, what we have done, we have find out the text relations with the ontology. So we have found some PubMed abstracts that were related to the disease ontology, and then we have extracted and linked the ontology with the text part, and then we are able to extract the axioms, intersection axiom and union axioms. So this is our first approach, like this is our first method in which we tried something like this that has not been done before. And this is very typical since the sentences are very complex, so it is very hard to recognize the entities. It is very hard to recognize the relationships among them. As you can see, the sentences are quite complex, and you are not the medical terms are quite complex itself. So that is why it is hard to extract these kinds of axioms from these kinds of texts. And for now we have achieved 14.2 F1 score and 19.08, and this is quite low, so we are working on it. We are using some deep learning methods so that it gets accuracies and the F1 scores can be improved. And you can find our poster at ESWC poster.github.io. So this was accepted in ISWC conference in which we presented it. And if you have time, I can play the video as well, but it contains the things that I already told you. So you can go through it, and then you can like browse over the data. You can find the video link here. You can find our paper as well. So this is the poster paper that you can find. So let me know if you have questions here. I think I'm out of time, and if I'll start the next module, I think it will be too late.
So I have
So
a
let me know
query
the
for you.
questions first. Yeah.
So the membership need not to be that much resolute. Quite possible that membership fuzzy also, like say one instance may do more than one concept.
Yes. Yes.
So then
Yes.
what would be the meaning of taking the union? So this is my first question. And second one is that to what order? I mean, are we only extracting the direct relationships or the indirect relationships also? So what is the order of the relation being extracted within the text?
Okay, so in this work, we are having an ontology in which we already know the concepts, right? And we are only interested in the entity linking part because we want to know the union and intersection among the concepts. So the relationship here, what we are focusing on is a kind of relationship. Is a means that like pneumonia is a disease, let's say. So disease will come in pneumonia part, and we are these are called a taxonomic relationship. We are not focusing on non-taxonomic relationship. This is also we are being focused, but it is on another work. For this work we are only focusing on is a relationship. So that is why I have not talked about the relationship part here, because the relationship is fixed and only the entity linking part is there, and after that we can calculate the union and intersection influence. About the second question, yes, there can be instances that are part of multiple concepts. For that, what we will do, so I have not gone through the details in here. So what we can do is, if we find the two concepts, let's say, and these are two related to each other, that means that it might come in the union after calculating the union exam, it might come under that also. So by calculating through the UMLS Mythosaurus, we will have the relationship among the entities, and if they are the descendant, then we will add into that on particular set only. If it does not, then the two instances can be part of the two concepts as well. So that can also be done.
Thank you.
And yeah. Okay. Any other question? I hope you understood because I have taken it from very scratch so that you get to know about how we have extracted them and why we have extracted them. That is very important. So there is this action.
I can see one more raised hand. Tamil Selvi S. Do you want to say something? Okay. I hope all good now. Yeah, thank you. Thank you so much, Miss Monica. And again, you have a session at 1:45.
Yes.
Along
So
with Miss Gunjan.
Yes, in the next session, I will be talking about ontology learning tools, the demo and everything. So that is very interesting. This is quite theoretical, and that was the next session will be quite practical.
Yeah, just to say that If possible, before start, as you have already introduced, Raghava has also introduced what is ontology learning. That is good in a manner, but for the unanimity of the session in itself, if you could introduce the motivation also for ontology learning for a few minutes, why are we doing it? So that it will
Yes,
be a
yes,
separate session as a whole.
sure.
Yeah,
Definitely.
fine.
Yeah.
So thank you so much. And thanks
no
for that. We had a wonderful time.
Yeah, no. Thank you.
Yeah. So we'll get back at 2:45 sharp.
Yes, sure.
Yeah. Okay. Thank you. Thank you so much. Bye-bye.
Okay. Bye.